Hi viewers, welcome to another video of Smart Pathshala. So in this session we are going to learn about some determinant practice problems and the inverse of matrix. Okay, as promised on the earlier video, right? Okay, so without any delay, let's start. Okay, so we are going to solve two problems in this session of determinant using the properties, and we are going to learn step by step the different algorithm to find the inverse of a matrix. Now say we are having a determinant alpha, beta, gamma, and then alpha square, beta square and gamma square, and then beta plus gamma, and then alpha plus gamma, and then obviously alpha plus beta. Now the problem is that we need to prove this determinant as alpha minus beta into beta minus gamma into gamma minus alpha into alpha plus beta plus gamma. Okay, this we need to solve using properties of determinant. Okay, now see, we can solve it directly by expansion, but it is not a convenient way to solve, because that will be very much haphazard. So we will solve it by using determinant properties. Now we will give some elementary operation, and that is R3 change to R3 plus R1, and obviously R1 and R2 remains same, and if you add them, what you will get is alpha plus beta plus gamma, and then alpha plus beta plus gamma, then again alpha plus beta plus gamma. Now take this alpha plus beta plus gamma out of this row 3 so that you can have alpha plus beta plus gamma, and in determinant you will have alpha, beta, gamma, and alpha square, beta square, gamma square. Okay, and on the third row we'll have a 1 1 1. Okay, now as discussed in the earlier video, that we have to make only 2 zeros in any of the column or any of the row, and then we have to expand it. Now we are getting 1 1 here, so now it become obvious then that we will convert only 2 zeros. Okay, now say we are changing C2 as C2 minus C1. Similarly we will change C3 minus C1. The target is to convert this 1 into 0. So we are getting it. Similarly gamma minus alpha, and then gamma square minus alpha square, and that's 1 minus 1, that means 0. Now it's easy. Expand it along row 3. So what you have is, if you are expanding along row 3, then obviously you are having beta minus alpha, and then alpha minus gamma minus alpha. You take this out of the dead box, that is, you are taking common beta minus alpha from C2 and then gamma minus alpha from C3. So now you are left with this stuff 1. Okay, fine. Now you have to expand along R3. Fine. So as you are having 0 here, so now obviously you have to write the cofactor of 1, and that will be the solution of your given determinant. Fine. So obviously it will be gamma plus alpha minus beta minus alpha. So you will get this alpha cancel, and you will have beta minus alpha into gamma minus alpha, and alpha plus beta plus gamma. Now just write it in a chronological manner that is given in the question. Alpha minus beta into beta minus gamma into gamma minus alpha into alpha plus beta plus gamma. Fine. So maybe it's raining outside. Maybe you can hear some sounds of raining. So it's a nice weather actually. Hence we proved it. Fine. Now let's dive into second problem of determinant. We are having a plus x into a minus x, and then a minus x, and in the second row we are having a minus x, a plus x, and then a minus x. Similarly we are having a minus x, and then a plus x. We need to prove it as 0. Fine. So similarly we will apply elementary operations, and C1 change to C1 plus C2 plus C3. Okay, what I have here, after doing this stuff, we are having 3a minus x, 3a minus x, and 3a minus x. So this thing is common. Now obviously, if you are following my lectures from the last to last video, then you can obviously say that what will be then my next step. The next step will be, I will take this 3a minus x out of that box. Sorry, the question was to I think solve this determinant, okay, not to prove. Okay, fine. So R2 change to R2 minus R1. We are doing this elementary operation. R3 change to R3 minus R1. So 3a minus x, 3a minus x, 3a minus x. And so we are having, take this 3a minus x out of that C1, then obviously you have 1, a minus x, a plus x. Sorry, a minus x. Now, as you are subtracting that R2, that is R1 from R2, then you will have the following determinant. Okay. Now that you are having two zeros on the first column, you will expand it along the first column, and then you will have 4x square minus 0. So we will have x minus 3a and 4x square equal to 0. Now obviously you can have the solution. Square into, yep, 0, 0, 3. Okay. Now say, in the previous videos, we were trying to solve the inverse of a matrix as like this. We are having an equation where we will have an equation like a square plus a plus I equal to 0, and then we use several types of methods to find out the A inverse. But in this lecture, we will learn how to find the inverse directly without having any equation or without applying some elementary operation. Okay. Now say we are having a 2 by 2 matrix as A11, A12, A21 and A22. Okay. Now the first step, okay, is to find out the determinant of A. If you find the determinant of A to be 0, then the inverse of A does not exist. Okay, do not exist. It is the inverse do not exist. But if determinant of A not is equal to 0, then A inverse exists and it is unique. Remember, this step is the first step in finding out the inverse of a matrix using this determinant method. Okay, now the second step. Second step is to find out the adjoint of the matrix A. What is the adjoint of the matrix A? Adjoint of the matrix A is the transpose of a matrix which consists of the elements of the corresponding position elements. Fine. A11. Okay. Now this A11 is nothing but the cofactor of A11. Okay. So what is the cofactor of A11? Obviously A22. You got it? I think you got it. Now that if you are doing the transpose, then obviously you will get capital A11 here and capital A21 here, similarly capital A12 here and capital A22 here. Okay, fine. Now let's, okay, now the third and the last step is to divide this adjoint matrix by the determinant of A. Hence you will have this inverse matrix. Okay. Now let's let me tell you some properties. If determinant of A is equal to 0, then this matrix is called singular matrix. Okay, and if determinant of A not is equal to 0, then this matrix is called non-singular matrix. Also, let us see some properties of inverse and transpose. Suppose AB whole inverse is given, then obviously you can write B inverse into A inverse and A inverse of whole transpose. That means you can also write A transpose whole inverse. If you want to know the proof, then you can inform us about it. We will try to submit it to you within a very short time. Okay, remember these formulas. Okay. Also, suppose A inverse is equal to 3 2 minus 1 2 is given. Suppose you are asked to find out A. Now remember one formula, A inverse whole inverse is equal to A, right? Now let us suppose we know this A inverse whole inverse is equal to A, fine. Now if you take A inverse as B, then obviously you can write B inverse is equal to A, fine. Okay. Now you are given with a matrix A inverse which is B, 3 2 minus 1 2. Okay. Now what you need to find is B inverse. Hence you will get A. Okay, now let us find out B inverse. The first step is to calculate the determinant. So 3 into 2 minus 2 into minus 1, which will give you 6 plus, fine, that is equal to 8. So now you have to find adjoint of B. Adjoint of B is the transpose of matrix the cofactor. So cofactor of 3 is what? 2. Cofactor of minus 1 is what? Minus 2. And then cofactor of 2 is 3, and then this 2 is plus 1. Okay. Now you have to do the transpose of this matrix. 1 and then 3. Fine. Okay. Now let me tell you a process by which you can find the adjoint of 2 by 2 matrix very fast. You just change this first diagonal elements and just change the sign of this second diagonal element. So that's a very tricky process. There is no rule, but it's a trick. Okay. Fine. In this step, in the third step, you need to find out the B inverse, and we know what is B inverse. That is adjoint of B by determinant of B. So obviously you have adjoint of B and then you have determinant of B. Just divide both of them and you will get B inverse, which means you are getting the A, and that is actually the solution. Remember, we need to apply properties in the right place at the right time. Now let's suppose we are having a matrix 1 2 3, 3 minus 2, 1 4 2 1. Okay. And in this problem we have been asked to find out A inverse. Now the first step is to find out determinant of A. What will be the determinant of A? 1 into minus 2 minus 2, minus 2 into 3 into 1 means 3, minus 4, plus 3 into 6 plus 8, and hence calculate it, minus 4, and then you have plus 2, then you have 14 plus 3. Okay, so you have minus 2 plus you have 42, then you have 40. Fine. So determinant of A is 40, and you need to write that determinant of A not is equal to 0. So A inverse obviously exists. Remember, you need to write this thing. And then coming to step 2, we need to find out adjoint of A. So what is adjoint of A? Adjoint of A is the big matrix of the cofactors and the transpose of them. Okay, now let's write the cofactor of 1 by 1. What is the cofactor of 1? Obviously, let us write it in determinant form. Minus 2 1 2 1. So write them in their position. Is minus 2 1 2 1. Fine. And here it is minus 3 1 4 1. Fine. And then here it is 3 minus 2 4 2. Fine again. And here you will have another one, here another one, here minus, plus, plus, another determinant with minus sign, and here will be negative sign, and then here will be plus sign. Now let us fill this with the numbers. Now at this position 3, we'll have the cofactor as 2 3 2 1. Okay, let us just write them 2 3 2 1. Okay, and then you just write the cofactor of 4. You are having 2 3 minus 2 and 1, 2 3 minus 2 and 1, and in place of that position we need to find out the cofactor. Go back to that matrix and then you will see that 1 3 3 1 is the solution. Similarly 1 3 4 1, and in this case you are having 1 2 4 2, and in this case you are having 1 2 3 minus 2. Fine. Now just write the value of this small determinant. So you are having here minus 4, and you are having in this position as 1. Okay, and here 6 plus 8, you are having 14, and here you have 2 minus 6, so you have minus 4, and then there is already minus there, so it is plus 4. And here you have 2 plus 6 8, and then this position you are having minus 11, and in this position you have minus 8, minus 8, okay, fine. Okay, just transpose the whole determinant. Now you need to find A inverse. So what is A inverse? Obviously adjoint of A divided by determinant of A. Then you need to write what is determinant of A. Determinant of A is 40. So 1 by 40 into, you see, yeah, so 1 by 40 into that minus 4 4 8 1 minus 11 minus 8 14 6 and minus 8. So this is the inverse of the matrix using determinant method. Maybe there is some numerical mistake in addition or subtraction, so you just have to learn the process. Okay, let's believe in process, not on the result. Okay, in the next video we'll try to solve some problems regarding simultaneous linear equation in 3 variable. I hope you guys enjoyed it, matrix method. Okay, now if you are having some problems regarding the Smart Pathshala or some mathematics, or if you are having some suggestions regarding to improve Smart Pathshala tutorials, then please suggest us. We are open to all, and maybe we are going to organize some quiz competition, so please participate on that. So thank you, see you on the next video. Bye.